Okay, so when we're looking at the domain and range, we always start by the domain. The domain is every single x value that you can put into this equation. So this equation here, right at the top, y equals 2x plus 1, we can put any x value in there. So the domain is all values of x or all real x. And when we look at this graph and we can zoom out and zoom out and zoom out, what values of y does it take? It takes on every single value of y as well. So we say that the domain and range of this graph is all real x or all values of x and all values of y. That doesn't always happen. Let's have a look at another one. Let's have a look at y equals x squared. So what is the domain and range of this? So if we think again of x squared, can we put every single number in that equation? We can put 10 in that equation. We can put 100 squared. We can put minus 5 squared. We can put a fraction in there. So the domain is every single value of x. And again, I can scroll out and you can see that every single value of x we can use. But what about the range? This, if I scroll out again, it looks as though that's only going to give positive values of y. And that's the case. Anytime you square a number, you get a positive. So the range of that function, even though the domain is all real x, all values of x, the range is x is greater than or equal to 0. And if we put a plus 5 here, suddenly the domain hasn't changed. We can put all values of x in. So the domain, all real x, but the range, what is the range now? The y values that we get are always greater than 5. And we can see that they're always greater than 5. We're never going to get anything less than 5, are we? But we're going to get everything that's greater than 5. What about the square root of x? So the square root of x is something that looks like this. Remember, if we had the plus or minus, that's not a function. That is not a function, so we don't care about that. It's a relation. We don't have a domain and range. We don't care. This is a function, the square root of x. Remember, x to the power of a half is really the square root of x. So what have we got there? We've got, well, x can't be a negative. If you can't take the square root of a negative number. That's why the graph does not exist over this side of the x-axis. It doesn't exist for x equals a negative number. So the domain is x is greater than or equal to 0. This is where sometimes the domain we look at first and say, where does it fail? It fails for this case, the square root of x, if x is a negative number. What are the y values? Well, the y values, it doesn't look like it, but it keeps on getting bigger and bigger and bigger, very slowly, but it keeps on getting bigger and bigger and bigger. So the range is all values of y. If we have a cubic, what about this cubic? Y equals x cubed minus 4x. Okay, so again, can we put every single value of x in here? Yes, we can. X cubed, yep. What are the y values? Well, again, we can scroll right out. Does it take on every single y value? Here are the y values down here, negatives, yep. So it actually takes on all real x and all real y. So any value of x it takes on and any value of y. Now, before I click on this one here, y equals 6 over x minus 2. Can we put anything in for x? Can we put anything that we want in for x? Well, we can't put 2 in because we can't have 6 divided by 2 minus 2 because we'd have a 0 on the bottom. Every other number we can put in, but we cannot put x equals 2. So that is our domain. All real x except x equals 2. And there's the graph of it. And what are the y values it takes on? And if we put in this value here, you see it can't be x equals 2. And we can scroll out as much as we want. it gets closer. It's an asymptote, isn't it? It gets closer and closer to 2, but it never actually gets to 2. So the domain, or the x values it can take, is all values of x except x equals 2. And what is the y value that it can't take? Because it doesn't look as though this y value can never be 0, can it? 6 divided by even a million, 6 divided by a million, it's not 0. It's very, very close to 0, but 6 divided by a million is 0.00000006. Okay. What about these circular things here? Okay, we'll get rid of those two because we don't want to confuse you. And we'll zoom in a bit. This is really x squared plus y squared equals 16. And then we've made y the subject, so this will graph it really nicely. X squared plus y squared equals 16. Is it a function? If we take the positive square root, it is a function. If we just do that, it is not a function. So again, because it's the square root of something here, this x squared can't be bigger than 16. 16 minus 17, well, you can't take the square root of it. That's why you get this circular thing happening. That's why the domain is between -4 and 4. What is the range? What y values can it take? Remember, the domain is the x values it can take. What the range is the y values. So what is the range from 0 to 4? Hopefully that's sort of explained. Once you've got the graph, it's easy to read off. Sometimes it's hard getting that graph.